The Dell XPS 15 is a thinner and lighter laptop that still has some fairly powerful hardware inside. So just how hot does it get, and is there any performance loss due to throttling? In this detailed thermal testing, you'll see how hot it runs and find out what changes can be made to improve performance. I've got one of the highest spec versions of the new Dell XPS 15 7590 laptop. There's an Intel i7-9750H CPU, NVIDIA GTX 1650 graphics, and 32GB of memory running in dual channel with a 4K OLED screen. The XPS 15 is available in quite a few different configurations, including i5 or even i9 CPU. You can find examples and updated prices linked in the description. Air is pulled in underneath the machine through the vents towards the back, then exhausted below the screen. Inside, there are just a couple of heat pipes shared between the processor and graphics with two fans. The Dell software doesn't offer much in the way of performance modifications. We can swap between the default optimized mode, cool, quiet, and ultra performance modes. I've tested all four in this video so you can see how they behave. Thermal testing was completed in an ambient room temperature of 21 degrees Celsius, so expect different results in different environments. At idle, both the CPU and GPU were approaching the warmer side, but no issues here. The rest of the results are from combined CPU and GPU stress tests, and are meant to represent worst-case scenarios as I run them for extended periods of time. These stress test results are from running the AIDA64 CPU stress test with only the stress CPU option checked, and the Heaven GPU benchmark at max settings at the same time to fully load the system. These are the temperatures we're looking at with the stress tests running in the default optimized mode, so it looks cool enough. If we enable the cool mode, the temperatures do drop back a little, and I'll let you listen to the fan noise differences a bit later. Quiet mode rose temperatures as the fan speed lowers, although the GPU was a little cooler than optimized mode. Ultra performance mode behaved a little strangely. Despite Intel XTU specifying the usual 28-second PL2 boost time, I found that for the first 3 minutes or so, higher CPU performance was possible, which is why the temperatures were hotter during this period. After the initial 3 minutes, the power limit was capped, resulting in more normal temperatures, well, at least normal compared to the other results. These are the clock speeds for the same tests just shown. The main thing I want to point out is that with the ultra performance profile in use for the first 3 minutes, we're seeing higher CPU clock speeds due to the power limit increase. I found it interesting that GPU performance was negatively affected though. The GPU clock speeds were lowered during the first 3 minutes, as if the power the GPU would otherwise be using was being directed to the CPU instead. We can see this in the power limits. For the first 3 minutes, the CPU power limit gets capped to a 30W TDP in ultra performance mode, and as a result, the GPU runs at around the 30W mark. After the first 3 minutes is over, the CPU power limit changes to 15 watts. However, the GPU is able to run at around the 42 mark now. It's worth keeping in mind that the GTX 1650 is meant to run up to 50 watts. So in this stress test, it's not getting enough power. The XPS 15 only has a 130W power brick. It seems that it has to choose which components get power and when, as power limits automatically changed based on workload. So far, we've only looked at workloads that utilize both the CPU and GPU together. However, CPU-only workloads are a different story. These are the CPU clock speeds while under a CPU-only stress test. We can see the speeds are much higher than what we saw previously under the combined workloads. When undervolted, we're almost reaching the 4GHz all-core turbo boost speed of the 9750H. This is simply because the XPS 15 is allowing a much higher 56W PL1. So with the GPU idle, it allows more power to be directed to the CPU under a workload like this. More power equals more heat though. So under this CPU-only stress test, we're now seeing much higher CPU temperatures, to the point where it's thermal throttling and hitting 100 degrees Celsius. I've got some Cinebench CPU benchmarks to demonstrate how this translates into performance. At stock, the results are a fair bit below many other 9750H laptops that I've tested. However, the undervolt moves it closer. Just for comparison, with higher power limits and adequate cooling, the 9750H can pass 3000 points in multi-core as a best case. If I instead run a GPU-only workload with the CPU idle, after a few minutes the GPU would thermal throttle, so it couldn't run with a 50W TDP sustained anyway, which is what a GTX 1650 should be capable of. As you can imagine, this funny business going on behind the scenes of power limits dynamically changing means that it's harder to get consistent results while gaming. While I am confident in the gaming benchmark results published in my previous video, I'll note that there was a little more variance between runs compared to other laptops, likely due to the behavior noted here. As for the external temperatures where you'll actually be putting your hands, at idle it was in the low to mid 30s, pretty standard. With the combined CPU and GPU stress tests running, it gets to around 50 in the center between the keys. However, it didn't actually feel hot to the touch, just a little warm, no problems here. Here's what the fans sound like during these different tests. At idle, it was completely silent, no fan noise at all. With the combined CPU and GPU stress test running in quiet mode, it was around 42 decibels. Cool mode raised this up a little to 45, and as we saw earlier, temperatures were improved a little by the faster fans. The default optimized mode was very similar to cool mode in terms of fan speed, while the ultra performance mode was just slightly higher at the 46 point. The fans never got louder than this, even in my CPU-only stress tests where the CPU was averaging 99 degrees Celsius and thermal throttling, so it seems like Dell are prioritizing quieter fans. Overall, the Dell XPS 15 was running on the cooler side, at least in combined workloads, and wasn't getting too loud. However, this comes at the expense of performance. Don't get me wrong, there's increased performance for shorter burst style workloads, especially for just CPU-only workloads. But combining both CPU and GPU together for an extended period of time will result in lower performance. I would have liked to have seen better fan control. The differences changing between the 4 modes in the Dell Power Manager software were quite minimal. I believe that Dell's G series was given that option through the Alienware Control Center, so it would have been nice to have fan speed adjustments here too. I kind of understand why they don't though. The XPS 15 seems to be a more premium device, and as such, I get the impression that Dell want it to run cooler and quieter, even if this comes at the expense of performance. Similar to what Apple do with the MacBook. To be fair, the main performance drop-off was after about 3 minutes into a heavy CPU and GPU workload. Perhaps most people hitting it less hard won't have any problems. If you need long-term sustained power, then I'd probably look at something other than the XPS 15 that can hold its clock speeds long-term. In the end though, I think user choice is the best option. Even if fan control requires some setting that's buried away or optional software download, it would have been nice to have. Improved cooling could allow for higher sustained power limits, thereby boosting performance. Instead, we're seeing lower performance than expected from this combination of hardware. Granted, the XPS 15 is a thinner machine, so that's not too surprising. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results, primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements, so don't just blindly copy my settings and do some testing to find out where your stable point is for best results. It may be possible to further improve temperatures by swapping the thermal paste. However, as this is a review unit that I have to send back, I'm not able to change the paste. Otherwise, the next reviewer will unknowingly report different results due to what I've done. Undervolting or using a cooling pad are much easier for most people to do than changing paste anyway. And as we've seen, these tweaks did help improve performance and temperatures with the XPS 15. Let me know what you thought about the thermals from the Dell XPS 15 laptop down in the comments. And if you're new to the channel, you'll definitely want to get subscribed for the upcoming full review to see everything this machine has to offer.